Good evening, everyone, and welcome to another edition of the Constellation Crew. I'm Rachel Williamson, the Planetarium Show Specialist here at the Ball State Planetarium. And tonight we have Alec and Ricky and Mel here in our discussion. And we have Caleb and Nicolette assisting in the chat. So feel free to ask questions in the chat or even answer any questions that we ask during the discussion if you by chance know the answer. So today's constellation is Cassiopeia, which is related to like 4 other constellations in the night sky, including Andromeda, which we talked about a few weeks ago in a previous edition. But before we get to tonight's constellation, I wanted to give a shout out to NASA's recent successful mission, OsirisRex, and it on October 20th of 2020, we successfully booped an asteroid. We touched the asteroid, and you can kind of see it shot out like a little bit of nitrogen gas to fling up a bunch of debris, so we could actually collect some of the material. From the video, it kind of looks more like a punch than a boop, perhaps. But we were able to collect material, and it's going to be brought back to Earth. And this is going to be the first time we'll have samples from other celestial body other than the Earth or the Moon. The last time we were able to bring samples back was in the moon missions. So let's get back to tonight's constellation, which is Cassiopeia. And to help us find it in the night sky, Mel, do you think you could help us out?
I think I can. We're going to look sort of northeast. So we talked about the Big Dipper and the Little Dipper and the North Star last week, which we can see here. So if you're able to find those, we're going to kind of go from the Big Dipper to the Little Dipper and kind of go that same distance about towards the northeast. So just kind of keep going. Cassiopeia can look either like an M or a W or an E or a 3, depending on the time of year. And Ricky's going to talk a little bit about why that is later. I like to think of it as an M because my name's Melanie and it's my favorite constellation, so I can pretend it was for me. So if you're able to find this sort of W shape, depending on the direction that it's facing, you have found Cassiopeia. So we'll give you a chance to kind of look for it on your own. So if you were looking there, you were right. It's sort of near Polaris, and I promise you it's there. I saw it last night. We're not just making it up. I swear that it's there. So hopefully you're able to find it tonight. But before we try to do that, we're going to talk a little bit more about the objects within Cassiopeia, who is a queen, I believe.
Yes, she's the queen.
And there's some pretty cool objects in there.
Yeah, I agree. So to start off with some of the featured objects, Alec, would you like to tell us what is special about maybe some of the stars?
Yeah, so there are about 14 stars that we found so far that have known exoplanets. So planets like we found in our solar system, but in another star system orbiting another star. And there's one that's really cool. It's got about 5 planets for that star. The star is called HD 219134. Wish there was a better name for it, but there's not. And the planets are designated like lowercase letters. And the one that we're looking at right now is B. And it kind of looks like a big hot rock, and that's exactly what it is. It's a rocky planet like the Earth, or Mercury, Venus, Mars, etc. But it's extremely close to its star, so it's really hot. It's about 1.5 times hotter than Venus. It's so hot because it's extremely close to its star. It's about 10 times closer to its sun than Mercury is to our sun. So that's really close. The mass is almost 5 times the mass of the Earth, but is only 1.5 times the radius. And it's actually about 20% more dense than Earth. So, but the gravity is only about 2 times more on that planet. So that's just how the 3-dimension scale and all that stuff. But it gets better. There's another one that's about the same size, is a little further out. I didn't mention the first one actually has a year of 3 days. So this one, next one, has a year of 6.7 days. So that's a big difference. And it's even denser. Its density is a little bit less than steel. So imagine having a planet that's just made of metal. That's pretty crazy. Then there's another one that's speculated that might be even denser than the ones I just talked about and bigger. Then there's one that there's a small possibility that it's an ocean world. So it's sort of like Earth, but like completely water. That's because it's around the area where you would expect liquid water, and its minimum mass is like 11 Earth masses. So that's pretty exciting. But the most likely scenario is that it's something like Neptune. But that's kind of cool. Neptune being where Earth is, or yeah.
Kind of like that movie Waterworld. It wasn't a very good movie, but
And then it's also got its own Jupiter. It's a little bit closer than our Jupiter, but it's about the same mass and all that. So pretty cool star system.
So there's some of the star systems, and you said like 14 of those stars have planets, and so,
yeah, that's just one of the star systems.
And that's just one of those 14. Wow. Okay. So there's a lot of exoplanets within the constellation of Cassiopeia. So there are also several nebulae in the Cassiopeia area. Ricky, would you like to tell us about some of those?
Yeah. First, just a quick reminder what nebula are. They're just big balls of gas in space that you can see, basically. So there's a couple different types, main types. So there's an emission nebula, reflection nebula, and dark nebula, which are kind of the most common. And they're really just named after what they do. Emission nebula, they're called that because they emit light. What we see from them, it comes from them. Reflection nebula, what we see from them isn't really coming from them. It's light bouncing off of other stars and other galaxies, and just coming at us. That's how we see it. Dark nebula are kind of special because they don't reflect light and they don't emit light. The only reason we know they're there is because there's something very bright behind them and they're blocking the light, but some gets through because they're just clouds of gas and dust. So we know that they're there.
Nice. So we've talked about a few nebulae in the past. Here are a couple of examples.
Yeah. So here we have on the left the Ring Nebula and on the right the Trifid Nebula. And the Ring Nebula is another type that I didn't mention before. It's a planetary nebula, which is really a subtype of emission nebula. And a planetary nebula forms when a star around the size of our sun gets to the end of its life cycle and it goes nova and dies. And when it does that, it outgasses. All of its stellar atmosphere gets pushed out, and the rest of what's left over, the core collapses down into a white dwarf. And then you get these nice, pretty pictures. So eventually, I think it's 5 billion years, when our sun decides it's done, it'll look like this. And on the right, we have the Trifid Nebula, which is special because it's the 3 types I talked about earlier all in one. So there's an emission type, the reflection type, which kind of the blue parts are the reflection types. The emission type are these red types that comes from all the hydrogen emitting the light. And then these dark kind of lines and circles that split it up into 3. Those are the dark nebula types. And then we have some of the ones that are actually in Cassiopeia. So this is the Heart Nebula. It's called the Heart Nebula because, well, it looks like a heart. You might have to crane your neck over to the side to see it, because it looks like a real heart, not the fake kind that you draw in school. Yeah, I mean, it kind of looks like that. I can see it a little,
Kinda.
but it looks more like a real heart. And this is kind of neat because since it's an emission type, that it's going to be producing mostly red light, and this is very close to what it would really look like if you were far enough away to see it like this with the naked eye. Um, it's about 7,500 light years away, and it has what's called an apparent magnitude of about 18, which is really just astronomer speak for saying that it's a billion times less bright than the sun when you look at it. It's not really that much less bright than the sun, but since we're so much closer to the sun, it looks like it.
Makes sense.
Hmm.
Is it just a specific element that makes it red, or?
Yeah, it's mostly hydrogen, because when the emission lines from the energy released from the electrons bouncing around, it's mostly in the red air zone for hydrogen, at least. And then we have the next one up. This is the Sol one. So it's called the Sol one because it's very close to the Heart one, and you always talk about the Heart and Soul at the same time, right? So it's also an emission type, but this one, it has, this is a composite image, it looks like, of multiple different bands. So instead of just seeing all the red from it, like we would if you were really there, you can start to see some of the other stuff shining through. The real cool thing about the Sol Nebula is that it's a very key in current research on how stars form. So you can see these little fingers that kind of point towards the centers of each of the two main holes. Each of those tips is where a star is forming, because what's happened is that the gas is flying outwards and some of it is denser than others, and it's not flying out quite as fast, and so they get a little closer to each other, and so they start becoming gravitationally bound, so it becomes even denser, and it's just a vicious cycle that eventually gets so much gas together that gravity takes over and it turns on and it becomes a star. And we get these nice pretty little shapes because of that, so thank you, gravity.
Yeah. Nice. Well, we have at least one more nebula. Alec, could you explain this nebula?
Yeah, so this one, you may have or may not have seen it already, but this one's called the Pacman Nebula. And it's called that because of its resemblance to the video game character Pac-Man. So the blue part is like the Pac-Man's yellow sort of body or head, whatever he is. And then you have his mouth is the big gas cloud that look like that's blocking the rest of the thing. So unfortunately, this one's also pretty dim. It's a little bit beyond what you can see with your eyes. So, but it's pretty cool to look at pictures of it.
Yeah. And we have at least one more cool feature called the White Rose Star Cluster. And I believe Nicolette is going to add a link to the picture of that one in the chat if you're curious. And Mel, would you tell us a little bit about this cluster?
Yeah, so with the picture in the chat, you're going to be able to get a little bit of a better look at it kind of up close. You can really go through all the different stars and everything. So it's called the White Rose Cluster, but it's also known as Caroline's Rose because it was named after Caroline Herschel, the person that discovered it. If that name sounds familiar, you may have heard of William Herschel, the pretty famous astronomer. That was actually his younger sister. So I guess their parents did something right. They had a whole family of astronomers. I'd be pretty proud.
Yeah.
So it's an open cluster. So kind of how we talked about globular clusters in the past. Really, the only difference between an open cluster and a globular cluster is that the open cluster has a decent amount less stars than a globular cluster. So it's less dense, it's less packed full of stars, which makes it more loosely bound because the gravity isn't as strong to hold everything together. But they are bound together still, even if it doesn't seem like it. They're moving together through space and everything. And all of the stars in the cluster are going to be about the same age because they were made from the same molecular cloud, which is similar to the makeup of a nebula. It's really just a big cloud of gas and dust like we saw in some of the other nebulas, which is pretty cool. I liked hearing about a woman astronomer. I always think that's really exciting.
Yes, I love women in astronomy. And that's not just because I am one.
I think astronomy was a little ahead of the times, wasn't it?
There seems like we're a good amount, which is awesome. Okay. So let's look at the daily motion, or nightly motion, maybe we could say, for Cassiopeia. And Ricky, could you kind of explain what's going on here?
Yeah. So we're going to have these stars. You can see the Big Dipper, the Little Dipper, and Cassiopeia. They're kind of rotating around, right? So these are examples of circumpolar constellations and I can't remember the word right now. I'm blanking. Not asterisms.
Oh, yeah.
So these are going to be circumpolar. What that really means is that they never set. So they never go below your horizon, and they really just kind of circle around, in this case, the North Pole. If you were in the southern hemisphere, you would have a different set of stars circling the South Pole. And a really neat thing about circumpolar stars is that it changes depending on where you are on the planet. So for us, we have our own set, but if you go further south, you get less and more stars that don't ever set.
South or north?
Or that don't not set. So if you go to the North Pole, all of the stars are circumpolar, and if you go to the equator, none of them are circumpolar. It's a much easier way to say that. And then we have this nice picture of kind of the stars tracing out the pattern in the sky. So you can see that they're all circling around this one point. And that's just caused because we're spinning.
I like the way Dana has explained it in the past, where it's like if every star had a piece of chalk and was dragging out a line behind it. But I like to imagine they had little hands and they were hanging out. They could have drawn the sky.
Wants to show you where it's been?
Yeah.
Yeah, that's a neat way to think about it. I like that.
Nice. Okay. Well, we can also briefly talk about Cassiopeia's mythology. So Cassiopeia in Greek mythology was the wife of King Cepheus, and she boasted that her and her daughter were the most beautiful women out there, even more beautiful than the Nereids, which were like 50 sea nymphs who were known for their beauty. And the sea nymphs or the Nereids, they were so enraged by Cassiopeia's baneful comments that they pleaded to Poseidon to punish her. And so the sea god sent a sea monster called Cetus to ravage the kingdom. And so the king and queen went to an oracle to try and get help. And the only way, he said, the only way that they had to appease the monster was to sacrifice Andromeda to the monster. So they reluctantly tied Andromeda to a rock right next to the ocean. But don't worry, she was actually saved by a hero, and we'll go into more detail on that next week. So the gods placed pretty much all of these characters from the story up into the heavens, and they punished Cassiopeia by making her be upside down for about half of the time. And that's because she's a circumpolar constellation for us. So sometimes she's upside down, so that's why sometimes it looks like a E, sometimes it looks like an M, sometimes it's a W, and sometimes it's kind of a 3. And I've seen the art drawn many different ways. Sometimes she's holding a mirror and admiring herself. Sometimes she's holding a palm leaf, which I think that's what this is supposed to be, even though it kind of looks more like a feather. And sometimes she's chained to her chair, which, well, she's upside down, might be kind of a relief. Don't have to hold for dear life that way.
She's going to end up really strong.
Yeah. So now that's bringing us to sunrise. So the constellations and the stars, they don't disappear. They're still there. We just don't see them because as the sun hits our atmosphere, it starts to scatter the blue light. And so we just can't see the stars behind. So let's look down on campus and see if you can tell what feature is kind of accented here on campus. Anybody recognize that? And it is a place on Ball State campus. So if you know where it is, you can put it in the chat. So I looked out at this a lot when I was a student here at Ball State. And do any of you guys know?
Duck pond.
Yeah, it's the duck pond out kind of by the tennis courts. So this would be Bethel Avenue, and we've got like really cool brick gate stuff here that's not showing up in this picture. I think this picture was probably taken before they were built, but those are very nice now. Okay, so that was Cassiopeia. That's the constellation we did. Here's some more art for it. And again, I think that's supposed to be a palm leaf, but it, again, looks more like a feather to me. All right, and we would like to say thank you to, I would like to say thank you to Alec, Melanie, Ricky, Nicolette, and Caleb for the amazing job you guys do each week on Constellation Crew. And I'd like to thank Dana Thompson, the planetarium director, for making these episodes possible. And a big thank you to every one of you watching, because you're why we do this. And we love to share our passion for astronomy. So feel free to come back next week to learn about the constellation Perseus. And until then, have a lovely weekend and a very safe evening.